Hi, my name is Jeremy. I am a fabricator and mechanic, and I am on a journey to build a replica 1937 Auto Union Type C. That said, this video has nothing to do with the car. This video is going to be a basics of milling machines and why I think my milling machine is one of the best that you can get as a hobby machinist, basically. Let's get to it. So real quick, before I get started on the specifics of this machine, I want to run through a bunch of terminology really quick, and then that way, as I mention things later, you have a reference in case you don't know anything about milling machines, which I'm sure some of you don't. But we will start with the basics of the machine. Come around here. This is what's known as a vertical knee mill, which means that the cutting implement, in this case a 3/4 inch end mill, is positioned vertically. The other main type of mill you will see is a horizontal. It's self-explanatory. The cutter comes out horizontally. Everything else is the same. The knee part is in relation to this guy here. So to go over some nomenclature, on this guy, the bottom here is the foot. This is the column. Up here is your belt drive system. Every mill is slightly different in how this is arranged, but these are your general guidelines. This is your spindle. This is what holds your cutting device. It's mounted inside of the quill, which moves up and down inside of the head of the mill. Down from there, the knee part comes from this guy here. This is the knee. This allows vertical travel of the piece that you are working on, also known as the workpiece, conveniently enough. It is run up and down by a large screw down there in the base. I don't think you can see it, but this handle is connected. You turn that, it goes up and down. That gives you one plane. Then above that is mounted the carriage, which moves for your perspective left and right, but when you're running the machine, it moves it fore and aft to, again, move your piece where you want it. And then mounted to that, finally, is the table. The table moves to your vantage point towards and away from the camera, but when you're running the machine, left and right. So those are your three axes of movement. Your table, left and right, is your X. The carriage, fore and aft, is your Y. And the knee, up and down, is your Z. So if you're doing any kind of plotting points, those are your three coordinates that you'll be going off of. Now the table has things in it called T-slots, which allow you to bolt workpieces, or in this case, a vise, to the table to secure your workpiece for cutting. So if you are a woodworker and you're used to holding on to stuff with your hands, that is a no-go here. Anytime you're using anything to cut metal, you want to, if it's precise, you want it to be firmly held and not able to get loose and destroy you. Now, specifically for this machine, this is a Kearney Trecker Model 2D Rotary Head Mill. So, you can see here, number 2 Rotary Head Milling Machine, Kearney Trecker Corporation, Milwaukee, Wisconsin. What does that mean? That means, if you remember earlier, the head up here that I told you about, that holds the quill, you can offset that up to 4 inches. And then while it is offset, you can rotate it. It has a power drive here that goes through this gearbox, up through this shaft, and rotates this whole head. There are degree markings here so you can see what it's doing. And that way you can cut circular patterns, or you can position it to whatever degree you want and cut diagonal slots, or you can cut really accurate bolt holes, like bolt patterns in a circle, 5, 6, 8, whatever bolts. It allows all of that to be done without ever repositioning the workpiece and without having a rotary table. These machines were made to do tool and die work, which means they are incredibly strong and rigid, which in a milling machine, rigidity is the main goal for a manual mill or even a CNC machine. The more rigid you can hold your part, the more accurate you can make your cuts. So if you think of a Bridgeport of roughly the same size as this, the whole head is loose. You can rotate it and you can nod the head as well. This machine does not have that, which is, it's a cool function, but eliminating those points means this is all one solid unit that is unbelievably rigid. And so the rigidity allows you to do extraordinarily precise work. And the fact that this has power feeds on everything except the Y means that you can control it to cut virtually any three-dimensional shape that is possible. If you are from the 50s and know how to do trigonometry on the fly with a pen and paper to figure out all of the rates of cut that you need to make a specific thing. And that is all done to make dies, typically. So if you think anything plastic you have probably was made with a injection die or injection mold. Anything metal that has to be strong is made in a forging die. Way back before that, die-cast metal toys were a big deal. All of those things are relatively low volume, but they need to be very precise to have the minimal amount of wastage and the minimal amount of cleanup afterwards. So these were made for that. What does that mean for a home gamer? That means that this machine is unbelievably capable compared to a Bridgeport. Which, if you don't know, Bridgeport is about the most common and famous brand of mill there is. They are extremely high quality. I'm not knocking them in any way, but they are more of a jack of all trades, master of none, whereas this is a dedicated, super precision machine. One of the things you'll see is the carriage is huge, and unlike a Bridgeport, it supports the table fully, end to end. The table is never hanging off in the air like on a Bridgeport, which again means that you have more contact surface on the slides, on the ways, that keeps this from having any kind of disparity. With that quick terminology lesson out of the way, I'm going to take the camera over here and I'm going to run you through all of the controls really quick. There are a lot, but I will try to get through them quickly because I know your attention span is like 5 seconds. So we'll start up here at the top. Over here you have your digital readout. This one is very cool in that it is from Boeing, 1976, and it works. Also, this machine was made in December of 1962, bought new by Boeing, rebuilt by them in 73. They added all this beautiful aluminum arm for the DRO, but we'll come back around here. So this is a digital readout. Right now I have it zeroed because I'm going to cut this. This is the compound off of my big Monarch lathe. To the right of the DRO, we have our start-stop switch. This was added by Boeing as well because this machine doesn't have an emergency stop anywhere because it's so old. So it's very nice that they added one. Then everything else is pretty self-explanatory. You have spindle rotation, table feed. You can turn this off, which I have off, so I don't accidentally bump the power feed on the table and then lose my zero on this. Coolant on and off. Coolant comes out of here. I use Qualichem water-soluble coolant. This originally was made to have oil, but it's such a mess, and the modern water-soluble stuff is so much nicer. So this runs on that. Then it has an air compressor, which I don't use because the air compressor was made to mix with the coolant for the oil to make an oil spray, and I don't mess with that, so it works, but I don't turn it on. To the right of that, we have our wheel for turning the rotary head. So if you see here, you can see all these really nice degree markings. With this guy, you can turn it. I have it disengaged, but you can turn it and then rotate this. There is a dial here for minutes and seconds, so you can get really precise. And then over here is your power feed. So if you pull this while the machine is running, first off, note that it kicks out your wheel. This will turn it clockwise, and backward is counterclockwise, anti-clockwise if you're British. Below that, we have our rotary head. Again, I have this all zeroed, so I'm not going to be moving it just yet, but You can see up here there's a Starrett scale, and you can see it goes over here to 4. With this, you have to loosen, there's a nut on the other side too. You have to loosen this, and then you can run it out rapidly with this handle, and then precisely with this guy. 1 turn is 100 thousandths. And here is the quill, so you can use this handle to run this up and down, or it also has a gearbox with 8 speeds, so it has power up and down feed. You can do the math to figure out ramps and like spiral ramps, anything like that. Very self-explanatory, you go up, down. It says in and out here. This is your range knob, in and out. It's stuck, but I don't really use the power quill feed for anything. This is the lock for the quill. So you tighten that up, and then that way you don't have your spindle drifting up and down. Here's the plaque for the spindle RPM. This one will go from 250 to 4,000, which is pretty fast for an old mill. To change that, you have to get up in the box. So they give you a nice step and then a handle. And then up here, there's another handle. So I'm gonna go up here. And in here, you have your first set of step pulleys. These give you your 3 major speed increments. And then back here is a variable sheave pulley that you run in and out to make the pulley basically larger or smaller in diameter. So it's basically an infinitely variable speed system. Up here in the very front, right up here, is your spindle lock for changing tooling and stuff. Here's that handle I told you about. And then if you want to, you can close this. I leave it open because it's just a pain. Also, they said originally if you're going to be running high speed for a long time, leave this open for cooling the motor, because the motor's down in here, and this is the only air in. So if you leave that open, it has more air to go out. It's also got this really nice hinge back here with the spring. Here is the motor and gearbox to drive. The rotary head has 16 speeds, and there's all on this chart here. Here is your storage door. I don't keep much in here anymore because I have the toolbox over there now. There's my old collet set. I got a new ER32 collet set, so I don't use those anymore either. Down in the bottom, those are the drains for the coolant in case it gets, if it runs over up here, it first will get collected in the trough on the vise, and if it runs over that, it goes back here, gets into this trough, and will run down into the base, back through those holes. On the table, you have all these channels that run into this strip back here that drains through this brass tube here into the base directly. Moving down, we have our vise. This is a Kurt D80. Really like it. It's very strong. It weighs like 270 pounds though, so taking it on and off sucks. Below that, this is the engagement for your power feed on the table, left and right. This wheel is your movement of the whole carriage fore and aft. So this is your Y-axis, and this is the up and down for the whole knee. So this is your Z. Also, these all have dials on them that are 1 full turn of the wheel is 100 thousandths of an inch, and then you can loosen these screws here, position this wherever you want, and then tighten this screw and reset your zeros back in the days before DROs. X and Y have these collars that you can pull in and out that then you can disengage the wheels so that you don't accidentally bump them and ruin your zero. Down there, and this and that are the DRO readouts. Over here we have our manual wheel for the table travel. Again, same idea with the collar to disengage it, and the same 100 thousandths per revolution. And then lastly, right here is the gearbox for table speeds. And again, we have 16 speeds, all very clearly labeled. On around over here, I added the hose reel just so I have a hose extension, and I also added an extension of my 220 outlet and a pair of 110 outlets. In here is all the electrics. Those are the motors for the air and coolant. Also, every axis has a lock. So you have a lock on your knee here. You have a lock for your carriage forward and backwards here. And then here is your table lock. So you have a lock on every axis. One thing, this is a 3-phase machine. So I do have from American Rotary, I have a AD10, which also runs the Big Monarch. So I have to start this to run the machine. So if you hear this in the background, know that's what it is. But basically this takes single phase 220 in, runs it through a bunch of magical stuff, and then some voodoo happens, and then out of here comes 223 phase. So we'll start this. And then turn this guy on. And you can see our lights have come on. So what I'm going to do now, this is the base of the compound for my Monarch, and it's been over tightened on the nuts for a long time apparently. So it's basically sitting high on these 2 points and then allowing it to rock. So I'm going to take off just a few thousandths of an inch and reface this whole cast iron face, and then I'm not going to abuse it. But I have already zeroed it on this pin, so I know my spindle is currently centered on this, which is what centers the whole compound. So what I'm going to do, I'm going to loosen this nut, like so. I'm going to also take off the locks for the rotation of the head, and then I'm going to press my start button over here, so the machine is now energized. I'm going to run out, get that out of the way, I'm going to run out my rotary head. You can see up here, it's kind of hard to see, I know, but we're running out on this, and we're going to go probably to the full 4 inches. And you see back here, the limiting factor is how tight it gets on the back there. We're going to go out the full 4 inches. And then I'm going to lock this nut again. I'm going to bring the table up. This is the power up on the table. It is only a rapid, so you cannot do power feed, but this is your rapid up. Table's coming up. Down is the other way, of course, and this is made on purpose so that you cannot hit the rapid while you have the wheel engaged. So you have to pull out the wheel, and then it has to center itself with this big counterweight before you can run in the rapid. But we'll run it up close, and luckily this guy is not more than 8 3/4 inches in diameter, so I will be able to redo this whole thing using the rotary head. Alright, I have my math done. I'm going to be turning this guy at about 450 RPM for a 3/4 inch 2-flute end mill in cast iron. I have over here guide plugged in for 5/16 of a revolution per minute, which will give me my roughly 3 inches per minute, slightly more, since I'm doing very light cuts. But then I believe we're ready to rock and roll. So let's start making some cuts. So I'm going to come up and I'm just going to barely touch this to get a witness. So I've walked this over 90 degrees off so that when I touch off, it will be at the lowest point. And then when it's coming through here, it'll be taken off the most to make it nice and level again. Okay, so we're touching. I'm going to zero my dial. I'm going to dial in 3/1000 of an inch. Let's see how she does. Look right here, we didn't touch. So we stopped cutting about here and stopped again here. So I need to come down another couple thousandths. We're at 5 total now. And we'll go the other way this time. Now I'm going to loosen the head again. I'm going to pull the spindle in 1/2 inch, and we're going to repeat. I actually went 600, but you know, YOLO as the kids say. And I also will go quicker on the rotation speed since my circle is now smaller. So I'll step up to a whopping 3/8 of an RPM. Now I'm gonna do the same thing again. That will conclude the video. I want to do a couple quick addendums though, just to hopefully answer some questions before they come up. These guys, these red things here are called T-slot covers, and I got them from Octane Work Holding. They're silicone and they're made for CNC machines, but it makes it so much nicer to clean up after you're done cutting if you don't have to dig stuff out of the T-slots. So I highly recommend getting some sort of cover for the T-slots. Nextly, there are a lot of oiling points all over this machine. You've seen all these little capsules and whatnot. I use this stuff, Domway 68, on both this and the lathe. It's been really good stuff. I really like it. It's really sticky and it stays on the ways. It doesn't drip down a lot. And then next up is what kind of coolant do I use? I use Qualichem Extreme Cut 251C. I looked on a bunch of CNC forums, and the guys on there said that this particular kind was really good at sitting for long periods. So in like a CNC shop, the stuff's running constantly. But for more of a job shop use, this machine may sit for a while, same with the lathe. And this particular kind doesn't allow the growth of the bacteria and stuff that causes normal coolant to start to stink and smell really bad and break down. And I have had really good luck so far. I've been running this for a year now, and I have changed it once because while I was painting all this and going through it, I decided I was going to take the coolant all out and put fresh in just because everything else was fresh. What else? Paint. So everything on this has been painted with Rust-Oleum. Up here is their gloss white. The reliefs are the gloss red, and the black is the gloss black. All out of their oil-based enamels, which are really good for this kind of application. They're really durable. They're fairly impervious to oils and coolants and things like that. And for anywhere you see yellow on this from the coolant or oil being on it, you can clean that up pretty quickly with just some WD-40 and a paper towel. The vise I did paint as well because it came from a CNC shop where it had been just doused with coolant for its whole life and stripped basically clean. And this was the closest I could find. This is also Rust-Oleum enamel, but it is out of the spray can. And whatever coolant they used on this kind of seeped into the pores of the casting. So it has held up really well so far, but you can see it's kind of shrinking and has wrinkles in the paint from whatever's under it coming up. But again, I don't remember what color it is, but this is the closest to Kurt color that I could find off the shelf. I really like the look. If you're gonna do this, it is a lot of work, but it does make the machine look gorgeous. Weight, just in case anybody's wondering. This machine weighs just about 6,000 pounds. It is heavier than most of these 2D rotary head machines because this has the wide table option, which makes your table 4 inches wider, I believe, and gives it an extra 8 inches of travel, I believe, because not only is the table wider, but also the carriage is wider. And that was a fairly expensive option back in the day, which this had. I found a price sheet originally with the wide table option adjusted for inflation. I think this thing is close to, today would be about $150,000 machine, I believe. So I got it for not nearly that much. But any questions that I didn't answer specifically, please let me know. I'll do my best to answer them. If you want more machining content, I really, really like ABOM79. He's my go-to. Super knowledgeable guy and has videos going back over a decade, I believe, on virtually anything you can want to know, especially about manual machining. He's getting into CNC stuff, but he has a huge catalog of manual machine work and endless tips and tricks. So I will tag him in the description. If you want really good quality machining videos, he's my number one. And then I also really like This Old Tony, he's more of a, I don't know how to say it. He's more of a broad picture type, where he will more script a video and have it be, he's very funny and have it laid out a lot, but he doesn't go into nearly as much depth. He's much more of a bird's eye view kind of thing. He gives really good information, but just because his videos are shorter and more compact and, shorter form, whereas A-bombs are much more of a in-depth, step-by-step, here's how I'm going to do this, and it's very, very, they usually are really longer videos for him, but they're super in-depth on detail and even where to find the stuff to know, like for instance, feeds and speeds on cutting this, where to find that information. I've mentioned the lathe several times. My next video, I probably will do a rundown of this lathe. Right now it is torn apart, so the carriage is completely off, and it's kind of in tatters, but it is a fully functional machine once I put it back together. I'll have a video on that. That'll be it for this video. Sorry it took so long to get out. I've had a lot going on. And then I also recorded this video 3 or 4 times, and every time it was too much detail on small things, and it was getting to be, I had one almost completely edited, and it was like 45 minutes before I even got to machining anything, so I came back out and just reshot the whole thing. If you want more in-depth, longer videos like that, let me know. They're more of a bear to edit, but if that's what you guys are into, let me know. If you want an hour-long video breakdown, deep dive on this machine and its really cool Boeing heritage and every in and out of it, I can do that too. If you want that, if you want the Monarch video to be that, also let me know. Because I feel like most people want a shorter form like this with a top-down kind of view and not the super in-depth stuff, but I could be wrong. More videos will be coming soon. I have a lot of stuff going on now that work has slowed down and I am capable of doing my own stuff again. Thank you for watching. Thanks for sticking around for my almost, once again, year-long break. But this time, I'm going to do more. I'm going to try to be consistent again because I believe I've got stuff in line. Like, subscribe, ring the bell, do all of the generic YouTube stuff that you have to do nowadays to engage with the channel. And I will see you in the next video. Thank you.